Hello everyone, today I'm about to explain logarithmic function. The log graphs. Okay, we have our common equation that we use where we have the log of b multiplied by x plus p base a. All together. This guy here is our vertical asymptote. This guy is our vertical asymptote, and then this one just indicates whether the graph will be on the left hand side of the asymptote or the right hand side of the asymptote. If b is greater than 0, therefore your graph will be on the right hand side of your asymptote. But if b is less than 0, therefore your graph will be on the left hand side of the asymptote. All together, and then a just tells you whether your graph is increasing or not. Please note that if a is greater than 1, therefore your graph is increasing. All together. But if a is between 0 and 1, therefore your graph is decreasing. All together. Please excuse me, please keep this in mind, guys. Keep this in mind. There are 4 sets of possible graphs that we have for the logarithmic function, and what's nice about this is that the logarithmic function is the inverse graph of the exponential function. All together, we have 4 sets. Firstly, please remember that our equation is y is equal to the log of bx plus q base a. Okay, we'll have our graph here, and we have our conditions. If a is a number which is greater than 1 and b is positive, simply means our graph will be on the right hand side of the asymptote and it will be increasing like this. All together. But if a is a number which is between 0 and 1 but b is still positive, simply means yes, our graph will be on the right hand side of the asymptote since b is positive. However, it will be decreasing since a is a number between 0 and 1. Our graph will go like this. All together. And then the third graph is just a reflection of the first graph, because everything is the same. A is greater than, let me not write it here, a is greater than 1, but now b is a negative number. It simply means that our graph will be increasing since a is greater than 1, but it will be increasing on the negative direction. So basically it's decreasing. Our graph will be like this. All together. And then same thing applies here. We have the graph in quadrant A, B, C and D. And the graphs in C and D are reflections of the above graphs. The graph at quadrant C is the reflection of the graph at quadrant B, and the graph at quadrant D should be the reflection of the graph in quadrant A. Here we still have the same condition. A is between 0 and 1, but now b is negative. Yes, our graph is still decreasing, but now it will be decreasing mostly where? On the negative. So our graph will look like this. Right, together. So these are the these are the types of graphs we will have. Right, together. You don't have to if you don't understand this, guys, you don't have to worry about the shape. The intercepts will guide you. The intercepts will guide you. Okay, let's say we have a graph like this. Y is equal to log of 2x. The most basic graph, ne? Log 2x, yeah, let's just leave it like this, log 2x. The first thing that you must know is that our asymptote is the y-axis. The y-axis will be the asymptote, y0, x-axis. Okay. The steps of drawing the graph are the same, ne? Firstly, find the asymptotes, draw them. Secondly, establish the shape. Then fourthly, find the x and y intercepts. All together. So my asymptote is the line x is equal to 0 this time around, and then the shape of my graph will be determined by a and b, ne? A is a number which is equal to 2, and 2 is a number which is greater than 1. All together. So my graph will either look like the one at A or the one at C. All together. But now the sign of B will help me to choose between the two. If B is positive, my graph will look like the one at A. If B is negative, my graph will look like the one at C. So B is a number that is always multiplying x. Right, together. So B is equal to 1, which is a positive number. So therefore the shape of my graph should be increasing like this. Are we together? And then for the intercept, x-intercept, I don't care what kind of a graph I'm dealing with, I always need to make y 0 and then solve x. In this case, I have y is equal to the log x base 2. Now when I make y 0, that means for me to solve x, I just need to for me to isolate x, that means I must remove the log, ne? That means I must just take the 2, the base here, and make it the base on the right hand side. Whatever that, the base on the left hand side, and whatever that was on the left hand side, it will become the exponent like this. I'll be left with x here. That means the x-intercept is at 1. Are you together? My graph, this kind of graph will never have the y-intercept. Why? Because the y-axis are my asymptote. So my graph will just look like this. It will be increasing like this, and it will pass when x is equal to 1. But if ever your graph does not have both x and y values, you must indicate an extra point on the graph. Anywhere on the graph, you can choose any x value. Are we together? I choose 2. If I substitute 2 whenever I see x, I know that I'll get 2 and the corresponding y value will be 1. When you punch your calculator there, by substituting 2, you'll get 1. Are we together? Now let's have one with asymptotes at least. Y is equal to the log of 2x minus 3. Same thing applies, guys, ne? Always the time. Whenever we write the vertical asymptote together, if we have a negative 3, it simply means that our asymptote will be at positive 3 altogether. So for asymptotes, we'll just say x is equal to a positive 3. You'll draw your Cartesian plane and indicate we have y 0, x-axis, that there is a 3 there which must not be touched. All together. Okay, so secondly, I must establish my shape of the graph. The shape of my graph. The value of a is equal to 1 over 2, and 1 over 2 is a number between 0 and 1. All together, b is equal to 1. Okay, so if b is equal to 1, ne? Which is greater than 0. Okay, let's go and check what shape do we have. I know that a is between 0 and 1, so it's either my graph will be the one at quadrant A or quadrant D altogether. But now, for choosing between the two, I'll be led by the sign of b. I've found out that b there is equal to a positive 1, and positive 1 is greater than 0. So my graph will look like the one at quadrant A. Right, together. So my shape will be like this. Then I must find my x-intercepts. My x-intercept, I don't care what kind of a graph it is, I just need to make y 0, solve for x. Y is equal to the log of x minus 3 base half. If I make x 0, I'll have this now, and then to remove the log, I must just take the base of half and it will become the base here. Whatever that was on the left hand side will be the exponent. Then I'll be left with x minus 3. Anything to the power of 0 is 1. Then x is equal to 4. I know that my graph will pass when x is equal to 4. For my y-intercept, I must always make x to be 0. But in this case, I don't have a y-intercept because I have the graph of log, then x minus 3 all together. Why don't I have a y-intercept? Because the index of the log, this number here is called the index. Né? This is the index and this one is the base. The index of the log has to be always greater than 0 all together. So, but if I put 0 there at x, that means I would have a log of negative 3, which is undefined because a logarithm index has to be always greater than 0. So that's why we don't have a y-intercept all together. So my graph will just go like this. No man, it's decreasing this time around. It will just go like this. And it makes sense that I don't have a y-intercept because I have my asymptote after the y-intercept. I know that this thing is 4 as I calculated before. All together. So all I need to do is to find an extra point on the graph. So find an extra point on the graph. It can be anywhere. It can be anywhere. I can choose that when when x is equal to 11, what is y? I know that I'll have 11 base half, then I'll have 8 there. I'll have, please just punch the calculator here, guys, ne? But because I know how to solve logarithms without a calculator, I'll do so. This is 2 to the 3, 2 to the negative 1. So this is 3 over negative 1, log 2 and 2. This is negative 3. Okay, I know that when my y value is 11, when my x is 11, the y value will be negative 3. If your graph does not cut both the x and y axes, you must indicate one extra point on your graph. Are we together? Please pause the video and do this one. Pause the video and do that one. Okay, let's go. Just you see. Okay. The asymptote. For the asymptote, you must x should be equal to 4. How did I get that? I know that. Let me write it in black. 4 minus x should not be equal to 0. That means 4 should not be equal to x. Just took the x to the other side. That's how I got my asymptote. Né? If you're struggling, just do this. Okay, and then now I must establish my shape. The shape of my graph. A is equal to 2, a number which is greater than 0. Are we together? But B is equal to a negative 1, a number which is less than 0. So for my shape, I need to go back there. A is greater than 1. That means my graph should be the one on quadrant B or C. But now B is negative. That means my graph should be the one that looks like the graph at C. Simply means that my graph will be at the left hand side, of the thingy, of the asymptote. Are we together? So will I be able to find the y-intercept, the x-intercept? Okay, let me check. X-intercept, I don't care what kind of a graph it is, just need to make y equal to 0. I have 4 minus x base 2. If I make y 0, what will x be? If I make y 0, okay, for me to remove the log, I must take the base here and make it the base on the left hand side. Whatever that was on the left hand side, it will be the exponent. So I'm left with 4 minus x. This thing is 1, 4 minus x. When I take x to the other side, I'll have a positive x, and I'll have 4 minus 1, which is 3. Are we together? And for my y-intercept, don't care what kind of a graph it is, I must make x 0, solve y. Then y is equal to the log of 2, 4 minus x. Y is the log of 2. I must just make x 0, solve for y. This is y log of 2, log of 4 base 2, and then y is equal to log of 2 okay, so y is equal to 2. If you are here, guys, just punch your calculator, it will get you straight there, ne? Y is equal to the log of 2, not log of 2, man. Y is equal to 2. So I know that I have a graph. I have a graph like this, ne? My graph has its asymptote when x is equal to 4, and my graph looks like this. It passes when x is equal to 3 and y is equal to 2. Y 0 x-axis. That's how my graph should look like. I hope you guys understand, and I hope this thing makes sense. Please wait for more. I'll be doing quadratic equation as well, quadratic function rather, and yeah, please stay tuned and wait for more videos.